Hello everyone. This video would focus on the parts of every ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the end point of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the end points of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the end point of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the a will be under the x. Now, we also remember that the value for a is always greater than b. And the equation that relates a, b, and c is c squared equals a squared minus b squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is h comma k plus minus c. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down, and so this is placed under the y. And we also remember that a is always greater than b, And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. If you found this video helpful, hit like and subscribe for more math videos. See ya!